Hi everyone. Our lesson for today is algebra, of course, lesson one. It's this all about the basic concept of algebra. Yeah, I want to discuss one, two, three, four, five algebraic terms, like and unlike terms, algebraic expressions, types of expressions, and the meaning of constant, variable, coefficient, squared term, cubic terms. All right, let's start with algebraic terms. What do we understand about algebraic terms? It's so simple that the terms we discuss in algebra are what we call algebraic terms. All right, so when you want to understand about algebraic terms, you have to consider what we call an expression. If we have 4x squared minus 3x, okay, this one is an expression. But this expression can only be possible if we bring in terms by putting them together using a plus or a minus sign between every two terms. Okay, so if we have 4x squared minus 3x, we have this term separated by a minus sign. Remember, terms are separated by either a plus or a minus sign. Only a plus sign or a minus sign can separate terms. Division sign cannot separate terms. Multiplication sign cannot separate terms. So therefore, this is an expression. But this expression contains how many terms? One, two terms. You see, the terms are separated by a minus sign. It could be a plus sign. What is important is that when you put two or more terms together, it will give us what we call an expression. But the two or more terms put together must be separated by either a plus or a minus sign. All right. So let's see something here. Terms are separated by either a plus or a minus sign. So let's say we have x, we have 3, we have x plus 3, we have 4x minus, or let's say 4x minus 1. So if you have x, of course, you can see it's just a single value. X is just a single value. So we can say this is one term. How about 3? 3 again is just another one term. X plus 3. We have x supposed to be a term, 3 another term. So when you bring them closer, you put them together using a plus sign between them, now the terms are separated. A term and another term. So now we have two terms. Okay, 4x. What do we understand by 4x? 4x is understood to be 4 times x, and 4 times x is 4x. 4 plus x is not 4x. 4 minus x is not 4x. 4 divided by x is not 4x, unless 4 times x that will give us 4x. When you divide 4 by x, it's not 4x. You add 4 and x, it's not 4x. You subtract x from 4, it's not 4x. But 4 times x is 4x. So if we have 4x, we want to know how many times. We already know that 4x is the same as 4 times x. But multiplication sign cannot separate terms. So this is just another one term. 4x minus 1. 4x is already one term. Minus 1 is another term separated by a minus sign. So here we have two terms. Now, if a bracket or an expression is multiplied by a number, specifically in the bracket, there are two terms. But when an expression is multiplied by a single number, or even an expression is multiplied by another expression, the result is one term. It's always one term all the time. Now let's say we have 4x plus 3. This one is an expression because two terms are added. Then we say x minus 1. This is another expression. So when you want to multiply them like this, it will always give us one term. So an expression multiplying another expression is always one term. An expression multiplying what? a single term is always one term. The product of an expression and a term is one term. The product of two or more expressions is always one term. So orally, if the question goes like orally, if the question goes like, what is the product of x minus 3 and 4x plus 1? Orally, the question says x minus 3, sorry, the product of x minus 3 and 4x plus 1. So it is wrong in mathematics to write it this way. So mathematics is not all about the answer or whatever, but what they approach the steps. So if the question goes like orally, I'm not saying if it appears like this in your question paper, This is what I'm saying. Like, let me say in your question booklet, if it appears like this, the case is different. But if orally it says, what is the product of x minus 3 and what 4x plus 1? You write it this way, it is wrong. So you have to use brackets. The reason being, in mathematics, if you write it this way, the result you get is different from this one. So the product of x minus 3 and 4x plus 1 can best be written this way to avoid problems. Okay. So back to the point. Now let's go to division, fractional cases. X over 3. How many times? X plus x over 3 plus 4. How many times? X plus 4 over 3. How many times? X over 4 minus x. How many times? Half of x. How many times? 2/3 divided by 4x minus 3 multiplied by x plus 1 over 4 minus 2 over 3x, let's say 1 minus 3 over 4. Okay, so first of all, how many terms do we have here? We have x as a numerator, 3 as a denominator. But between the two values, there is a division here. Division cannot separate terms. So this gives one term. X over 3 plus 4. This is already a term. Between this and 4, there is a plus sign. A plus sign can separate terms. So we have two terms. Okay. Here, specifically, the numerator contains two terms. The denominator contains one term. But this division line carries everything we have on the side of what? The numerator. So the fact that this one carries everything the numerator has, that makes this one again another one term. Likewise here, the numerator contains one term, the denominator two terms. But the division line covers everything we have. Yes, we have for what? The denominator. So this is another one term. Okay. How about half of x? What does off represent in algebra? So when we talk about off here represents a multiplication sign. So half of x is like half times x. Multiplication sign cannot separate terms. So how many terms do we have? We have one term. Okay. We have a very lengthy one here. So to do this one, let's do it step by step for every two terms. Now, between this term and this term, what we have between them? Division. Division cannot separate terms. So this and this is one term. Between this term now we have and this term, we have a multiplication sign. Multiplication sign cannot separate terms. So the same term continues. So what do we have? We meet now a minus sign. Minus sign separates terms. So this term ends here. We now have one term. So 2/3 of x is one term. In the bracket, there are two terms, but the product of a bracket and any value, be it a single term or expression, is always one term. So here is another one term. So now we have two terms. So all this we need to understand that are very much important. So now let's go to the second point. The second point is about like and unlike terms. The second point is like and unlike terms. All right. So what do we understand about like terms and unlike terms? So when we talk about like terms, so we say the powers and the variables must be the same. If the powers and the variables are the same, we say the terms are what? Alike. If the terms, are what? The powers and or variables are different, we say the terms are what? Unlike. Let's see the example here. Now we say 4x and 3x. So for like and unlike terms in basic algebra, it's all about variables and powers. Okay, now let's check for the powers. The power of this x is 1. Remember, if your eyes cannot see any power, it means the power is 1. That is what we understand from indices. Okay, the power of this x is 1. The power of this x is 1. The powers are the same. Let's go for the variables. Here is x, here is x. The variables are also the same. So both the powers and the variables must be the same before we say these two terms are alike. So what can we say? These are like terms. Let me just do it this way. So if we have 4x squared and minus 3x squared, for the knowledge of like and unlike terms, it has nothing to do with what is in front of the variables, which we call coefficients. So the coefficients we have here do not matter. All what is matter is what? The powers and the variables. Okay, let's check for the powers. The power of x is 2, the power of x is 2. The powers are the same. Let's see for the variables. We have x, we have x. The variables are the same. So when both the powers and the variables are the same, we say this and this are like terms. So these are like terms. So let's see another one here. Minus x squared and y squared, or let me say 3y squared. Let's check for the powers. The x has a power of 2, y has a power of 2. The powers are the same. Let's check for the variables. The variable here is x and here is y. The variables are not the same. So if the powers are different, the variables are different, or both the powers and the variables are different, we say they are unlike terms. If the powers are different, they are unlike terms. If the variables are different, they are unlike terms. If both the powers and the variables are different, they are unlike terms. If the powers are the same, but the variables are different, unlike terms. The variables are the same, the powers are different, they are unlike terms. So they can only be like terms if both the powers and the variables are the same. Okay, let's see another example here. 2x squared y and minus 4x squared y. Don't be confused by the coefficient 2 and minus 4. Forget about them. Consider the variables and the powers. X with a power of 2, x with a power of 2. The powers are the same. Y with a power of 1, y with a power of 1. The powers are the same. Let's go for the variables. This x is here. This y is here. So both the powers and the variables are the same. So these are also like terms. So if we have half xy squared and 45x squared y, Okay, let's see. This time around, let's check first for the variables. This x is here. This y is here. So the variables are the same. X is here, y is here. The variables are the same. Let's see for the powers. The power of x is 1. The power of x is 2. If I were you, I would not even bother to check further because x is 1, x is 2. So no matter what happens with the powers of y, the fact that the powers of x are different, the two terms are unlike. X is 1, x is 2. So if we further check again, y is 2, y is 1. So these are unlike terms. So we have other critical cases again. xy squared and y squared. Xy squared and y squared. Okay, let's check for the powers. The power of y is 2. The power of y is 2. So the powers of y are the same. X with a power of y, 1, there is no x here. So the fact that there is a variable that present or that fails to present in all of the terms that are provided, it means they are unlike. So what claims can we make here? We can say the variables are not the same because there is x here which is not here. So these are unlike terms. Unlike terms. The final one is 2m squared n and 3 minus 3 n m squared. Let's check for the variables. M is here, though here it comes after. N is here, though here it comes before. So the variables are the same. The conditions, we don't have any condition that says if the order is not, if the variables are not in order. We don't have that condition. The only conditions we have if the variables are the same and the powers are the same, or if one of them are different. Okay, m with a power of 2, m with a power of 2, n power of 1, n power of 1. So it doesn't matter which one comes before which one. The variables are the same, the powers are the same. So these are also like terms. Okay, so we go to expressions. We go to expressions in algebra. Algebraic expressions. All right. So as I was saying, when you put two or more terms, using a plus or a minus, we get an expression. We have this term, we have this term, we have this term. Three terms are brought together to form an expression. So this is an expression. This is an expression. It contains how many terms? Three terms. The first term, the second term, and the third term. So there are three terms in this expression. Okay, so this is what we mean by what? An expression. An expression is the combination of two or more terms using a plus or a minus sign. Okay, so the fourth one, let's go to types of expression. Now we have 4x minus 3, 3x squared minus 3x plus 4. Okay, so for one term, we call that one monomial. In algebra, a single term is called monomial. Remember, mono means one. Then for two terms, any expression containing two terms, we call it binomial. We call it binomial. So when we say bi, it represents what? Two. Then an expression containing three terms, we say trinomial. So tri, it means three, like we say triangle. Okay, so this is an expression containing what? Three terms. This one contains two terms. This one contains one term. For one term, monomial. Two terms, binomial. Three terms, trinomial. So this in algebra, it's unlike in chemistry. They have like what we call tetraatomic. Okay, but here we don't have anything like tetra. So we talk about what? Monomial, binomial, trinomial. So the last one is poly. So what do we understand by poly? Poly means many. So polynomial. But the unique thing about polynomial is that any of these ones can be a polynomial. Any of these ones can be a polynomial. All of these ones are polynomial, whether it's one term, two terms, three terms, or more terms, four terms, 50 terms, 10 terms. All of them are what? Polynomials. Okay, so now let's go to the meaning of constant, variable, coefficient, squared term, and cubic term. Okay, so I will just explain all of them once. Now let's say we have 2 pence. Then we say we have x pence. In mathematics, if we say John has x pence, no one can tell how many pence. It could be John could have like 5 pence. If we say John has x pence, it means John can have 10 pence. John can have what? 5 pence. John can have 1 pen. It's possible that John does not even have a pen. Yeah, because we say x pence. So it could be 0. It could be 10 pence, 1 pen, 4 pence. So that's what we mean by what? X. But if we say John has 2 pence, we know exactly how many pence John has. So 2 is a specific number that makes it a constant. 2 is a specific number that makes it a constant. This one can take many values. It can take what? Different values. So the reason we call it a variable. So, but the concept of variable, it also depends the specific problem you are solving, the specific topic you are discussing. Now, let's say you have an equation like this: 2x squared minus px plus 3 equal to 0. Now, the question says, find the value of x for which the equation has two real values. So in this case, they don't want the student to be confused with what? P as a letter. So most cases, if not all, they will inform you that where P is a constant. So what does that mean? It tells you that despite P is an alphabet, but treat P as the way you treat any of the numbers. So in that case, 2 is a constant, 3 is a constant, P is a letter. It seems to be a variable. So the question will inform you, or the examiner will inform you that P, where P is a constant. So it means you don't treat P to be a variable. Otherwise, any letter you see, it's a variable, except otherwise. We have letters like pi. We have cases wherein they will treat pi to be a variable. Otherwise, pi is a constant. Yeah. Otherwise, pi is a constant. But we have specific cases wherein we can tend to use pi to be a variable. For example, they will say pi squared minus 3 pi plus 2 equal to 0. Basic algebra. The teacher can say, find the value of pi. So you cannot say because you see pi or because you have been informed that pi is 20/7, you can say, well, since I see pi, how can I find pi again? I have been told already that pi is already 20/7. No, the case is different. Okay. So this is what we mean by what? Variable. Sometimes the word variable comes from what we say varies. Yeah. Today I'm making this video, let's say at 12 noon. Yeah. Tomorrow I can make another video at, let me say, 11 a.m. Yeah. Yesterday I did one at 1 p.m. So if someone asks me, when do you normally do your videos? I will say, well, I can't tell. The time varies. So because I don't have a specific time, the time varies. There we have the word variable. So once we say X, it could be mean what? It could mean different values. If today you find the value of x to be 1, maybe the next problem your value of x will be minus 2.5. Maybe some other time it will be 0. Another time it will be 1 over 2. So this is what we mean by what? Variable. And this is what? A constant. Okay. Now, what do we understand about coefficients? Is what we have in front of the variable. 2 is the coefficient. P is the coefficient of x. 3 is not a coefficient because it is the term does not contain a variable. So 3 is a constant term. This term, the coefficient is minus p. This term, the coefficient is 2. But specifically, for explanation, sometimes we can say, what is the coefficient of x squared? So saying coefficient is like saying what is standing with, or what is standing in front, or what is standing by. So the coefficient of x squared means in this term, apart from x squared, what else do you have? It is 2y. The coefficient of x simply means this term, what is standing in front of x? It is minus p. That is what we mean by coefficient. What do we mean by squared term? Squared term is the term where the variable has the power of 2. So 2x squared minus px plus 3 equal to 0. And we say which term is a squared term? This is definitely the squared term. This is what? The x term, or the term in x. This is what? The constant term. So if we have another term here like 4x cubed, the term with x cubed, or the term with a power of 3 is what we mean by what? The cubic term. Okay. So don't forget, when we say square, we say power of 2. When we say cube, we mean what? Power of 3. So this is all we have for this video. Thank you for watching. Don't forget to like, share, and comment. Bye-bye.